Okay, hey there, this is Mr. Wolf. This is my first video attempt at a lecture, so bear with me here. This is a learning process for me and you. So, here we go. We're going to be starting with benchmark 18. I can solve problems using trigonometric ratios for right triangles. So we're still going to be working with right triangles, and you're probably looking down here at this weird word wondering, oh my gosh, what is that? Well, I'm going to get into that in just a moment, and you'll see how helpful this word will be. As we move along here in this lecture, be sure you're taking a few notes. Remember, we remember 80% of what we write down as opposed to much less when we just hear. So take a few notes. It'll save you time in the long run. Just some basic introduction information. Where does trigonometry come from? Well, the word comes from the Greek, trigonometria, and when you break that word down, it actually means triangle and measuring. So trigonometry, triangle, and measuring. So we're measuring triangles here, and we're going to use some of the universal properties of triangles that we've already learned about in order to find out some more information about a given triangle. This is the vocabulary that we'll be working with today. Trigonometric ratio, sine, cosine, and tangent. You've probably seen these words before, and now you're going to find out what they mean. So here we go. You'll remember when we did the benchmark 15 similar triangles that a right triangle with any given acute angle is similar to every other right triangle because of the AA similarity postulate. So each of these triangles down here are similar. You'll recall that similar means same shape, but different sizes. So we know each one of these has a right angle. It's labeled with the red box. And we know that each one of them has a 32-degree acute angle. And due to the triangle sum theorem, we know that the third acute angle will be the same in each one, in this case 58. So all these triangles are similar. If you're given two angles of a triangle, there's only one other angle that it could be. So we only need to know a couple small things about a triangle in order to know all things about that triangle. And that's the basic information that we need going forward here. For our purposes on this benchmark, we'll need to understand that the three sides are called opposite, adjacent, and hypotenuse. Now you already know which side is the hypotenuse. You'll recall that the hypotenuse is the side that is opposite from the right angle. And we usually call that side C. It's also the longest side in the right triangle. So that should be something you're already familiar with. So which side is opposite, which side is adjacent? Well, that depends on which angle we're talking about. Let's say that we are using this particular angle right here. Ooh, I don't like that pin. I'll use this. Okay, we're using angle A. Okay? In reference to angle A, this side over here will be your opposite side. Okay? Which makes the side right next to it, right here, your adjacent side. Alright? I hope that makes sense. If we were talking about, let's get rid of this here. Get rid of that, and get rid of that. Okay. Now let's back up. Let's say that we're referring to this angle here. Well, in that case, this side over here becomes the opposite, and this side here is adjacent. That should be fairly obvious. And of course, you know that this side over here is still, and always is, the hypotenuse. Okay? So being able to identify which side is opposite, which side is adjacent is crucial to using the trig ratios. It just depends on which of the two acute angles we are working with. Okay, let's get into what these actual words mean, and then we'll talk about how we use them. First sine. The sine of an angle is the ratio of the length of the leg opposite of the angle to the length of the hypotenuse. Okay, so you'll see that the sine of angle A here, the sine of angle A is the opposite side over the hypotenuse. And over here, they've said A over C. Opposite over hypotenuse. If we were doing the sine of B, angle B, well, then we would use B as the opposite, side B over C. And you'll see that labeled right here. Okay, so sine is opposite over hypotenuse. That's all one must remember. Cosine, you see, looks very similar. Cosine is the adjacent over the hypotenuse. Okay, so if we're talking about the cosine of A, here's A, get rid of that. We're talking about the adjacent side, which is B over hypotenuse, B over C. If we're talking about the cosine of B, then we're talking about A over C, and you see that here. Cosine is adjacent over hypotenuse. Okay, and the last term is tangent, and tangent is the opposite side over the adjacent side. So if we're talking about the tangent of A, we're talking about the opposite side, which would be A, over the adjacent side, which is B. And that's listed here, A over B. If we're talking about the tangent of B, we just flip it, B over A. And you notice on all these examples, we're never talking about angle C because we already know angle C. It's 90. Okay? So at this point, you're probably thinking, that's a lot to remember. Well, let's go back to that funny word that we saw earlier. We call this SOHCAHTOA. SOHCAHTOA. Yeah, it sounds funny, but it helps us remember what each of these terms mean. Okay, so let's focus first on the SO. So, S-O-H. Okay, the S stands for sine, the O stands for opposite, and the H stands for hypotenuse. So, we end up with sine is opposite over hypotenuse. Ta, the C stands for cosine, A stands for adjacent, and H stands for hypotenuse. So cosine is adjacent over hypotenuse. And TOA, you've probably guessed, is tangent, is opposite over adjacent. Tan, opposite over adjacent. And it's probably worth pointing out that we usually abbreviate sine, cosine, and tangent, sin, cos, and tan. So don't get mixed up, that's just an abbreviation. All right, so SOHCAHTOA helps us remember what these ratios actually are. All right, so now that we understand how to label the sides, adjacent, opposite, and hypotenuse, and we understand that the ratios, sine, cosine, and tangent, are these right here, okay, let's move forward here and figure out, all right, which one do I use? So what I've done is created an example triangle here. It's a right triangle. It looks isosceles, but we don't know for sure because in geometry, looks can be deceiving. So for this example, let's say that we're using, well, I think I'll use the calligraphic pen there. Okay, let's say that we want to figure out what is this angle A here. Okay, we don't know what this angle is, but we can find it out. So we've got angle A, all right, and we know the opposite side is 9. And we know the hypotenuse is 12. And I'm going to go ahead and I'm going to get rid of this 8 to make it a little bit more challenging for us. So we don't know this side. Let's pretend we don't. We know this side is 9. We know this side is 12. We know that this side, hold on here. We know this side is opposite from angle A. And of course we know this side is the hypotenuse. Now, we have the opposite and hypotenuse. Let's flash back. Which one of our three ratios contains opposite and hypotenuse? Is it sine, cosine, and tangent? Well, it's easy to see opposite and hypotenuse is sine. Okay? So the sine of angle A is equal to the opposite over hypotenuse, and in this case that is 9 over 12. There you go. 9 over 12. All right, see how that works? The ancient Greeks have already done all the work for us. 9/12 means nothing to us. We still need to know what this angle means. What the Greeks noticed was that no matter what triangle you have, if you have a triangle with a ratio 9/12, and when you divide that in the calculator, you'll notice you get 0.75. They found out that when the opposite over the hypotenuse equals 0.75, this angle can only be one angle. And we have tables. They created tables to help us out. And you see all of these different ratios here. So we're dealing with sine, and we would go all the way down, all the way down. Oh, it's not even on this column. Over here to where we find 75. They don't even have 0.75, but they're close. And it looks like our angle is going to be about 49 degrees. Okay. Now looking up on a table is that's that's kind of a pain. Luckily, our calculators are programmed, and you'll probably notice right here these buttons that you've seen all year: sin, cos, and tan. Now you know what those stand for. Okay. We have all of these ratios already plugged into the calculator. Okay. So all we have to do is put in sine 0.75, and bam, we know our angle. Okay. Let's flash back here. Let's do a little different here. Let's do let's say we want to do angle B. All right. Angle B. Let me get my pen back up. All right. Okay, we still have our hypotenuse, but what's changed? Well, what's changed is this is not the opposite side, is it? Now, let's get rid of that. And let's go ahead and get rid of all this. So now, this side here to angle B is actually the adjacent side. All right? So now, we have to think, all right, which one of our ratios uses adjacent and hypotenuse? And if you go back to SOHCAHTOA, all right, SOHCAHTOA, which one has adjacent and hypotenuse? And you see, yep, it's cosine. Cosine is adjacent over hypotenuse. All right, so the cosine of angle B is equal to 9/12. All right, and we would do the same thing. We would go back to our calculator, but this time we would hit cosine, and we would hit 9/12 using the fraction key, or you could do 0.75. Either way, you're going to get the same thing, and it tells us the angle. If we use the chart, we would float here to about 0.75, all right, on the cosine column, and we see that the angle is roughly 41, 42 degrees, okay? So let's go back to where we were. All right, so when trying to determine which one you use, you need to know which angle you're trying to find, all right? And once you know what angle you're trying to find, figure out which sides you have, all right? If we have this side, and we're looking for angle A, well, that's adjacent over hypotenuse, okay? If we have this side and this side, well, that's an opposite over hypotenuse. We would use sine, all right? And let's say that we have this side and this side, we're still looking for angle A. Well, we have opposite and adjacent, and that's going to be tangent. And you just apply the same steps on the calculator, okay? So let's sum up here. We learned that in using the trig ratios, let me get a triangle up here. All right, we learned that first off, we have to be able to identify each side. All right, we already know this is going to be the hypotenuse. All right, and then depending on, that's our right angle, depending on if we're looking at this angle or this angle, okay, then these sides will be opposite, and adjacent, okay, or those could be flipped around depending on which angle. All right, and we also learned that to remember these ratios, we use SOHCAHTOA. All right, the sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. Okay. There is a very quick quiz to take just to demonstrate that you watched the video and you understood a little something. So on the website there below the video, please click on the link. It's like a 5-question quiz. Most of it's multiple choice or short answer, so it should take you about 1 to 2 minutes to take. And that way tomorrow you'll be prepared whenever you come to class, and we can actually do the homework and activities in class instead of you doing it at home. Okay? Remember, if you have any questions, you can always hit up my text line. That's at 816-286-4430. All right, that ends my first web video. It's Mr. Wolf, signing out.